I am Alice Guionnet, researcher at CNRS, based at École Normale in Lyon. We are actually now in my office. And I'm giving this interview because the organizer of the ICM asked me to give an interview about myself. So it's a quite scary thing to do for me, and I was very much relieved when Christophe Garban offered me to interview me. So Christophe Garban is a very good friend. He's a professor at Université of Lyon, working in probability like me. And we are together editor at the Annals of Probability. And we usually have lots of fun together. So I just thought that this moment, which could be quite boring, could become a lot of fun if he interviews me.
I'm very pleased, also very honored to play a bit the role of a journalist. And I will try my best for those of you who will watch the video to get to know Alice better as a mathematician, but also as a person. So I will start with a first question, which is about the beginning, and more particularly the maybe memories you have from your childhood, maybe high school, where you started to be in touch with mathematics.
So I was in touch with mathematics quite early at school, of course, but I really wanted to become a researcher pretty late, actually, only when I started my PhD, so which is quite late indeed. And when I was a kid, I just wanted to be an engineer, like my father. I went to a good school for that, which is Louis le Grand in Paris. And high school went well, and then I decided to go to classe préparatoire. So classe préparatoire is a quite French thing. It is 2 years of intense training to try to do some exams to enter the best school in France. And I did that also in Louis le Grand. So there I was in touch with lots of mathematics, but it was really tough. I mean, I really thought at some point I would never make it. And fortunately, even though it was very hard, I got very bad grade, like 3/20 a couple of times. I really thought it was the end of it. And one day, I remember I had this exam where it happened that I had made it, half of it already by when I trained. And then, so I had a very good grade. And at that point, suddenly I realized that I could make it, and I think also maybe the professors thought I could make it. And from that time, I succeeded pretty well, and I succeeded very well the exams, and I had the choice to go in the best possible school I wanted. So that was how I really got confirmed that I could go to science and continue from there.
Good. So after high school, if I'm not wrong, you go to a classe préparatoire, and you have the two best schools. One very engineer-oriented, École Polytechnique, and one more research-oriented, École Normale Supérieure. And suddenly you change plans.
Yeah, so that's true. So what happened is that I realized at that point that these two schools were very good, and I wanted always to do Polytechnique. Actually, I tried to enter École Normale a bit by chance, because a friend told me, you know, the exam is free, you have nothing better to do that week, so you can try it. And indeed, I tried, and I was lucky enough to be accepted. And so, but it was really by chance. And then I just realized that if I go to Polytechnique, I have to do the military service, which was something I never thought I would have to do. And I was very happy when I decided to go to École Normale, not to have to do the military service, and eventually still become an engineer.
Okay, and so you left aside the engineer career maybe for at that moment, and in a few years, I guess 1-2 years, I don't know at the time, but you go to probability. So can you tell us how you went from all mathematics at the beginning of École Normale Supérieure and progressively to choose probability theory?
Yes, so in fact at École Normale it's still quite intense, because in 1 year you have to do, at least at the time, we had to do 2 years. So maîtrise and licence. And so at the end of that year, you have to choose what you are going to do in master, so kind of which will direct you to what you are going to do later on for your PhD. And so how did I decide? I think I liked analysis, this was clear, and probability was for me so a domain I liked, but also which was keeping lots of doors open, because probability is connected to many things, to computer science, to physics, to finance. I mean, there was this possibility to go to banking afterwards, so I just thought that it was a domain I really liked, but still which would keep all my doors open, because for me doing research was still something I did not really imagine.
So you left many doors open, but at some point you decided to go into a PhD. And so maybe this is a crucial part of a mathematician's life. So maybe my first question about the PhD is, how did you get to choose the PhD advisor, Gérard Ben Arous, and the subject? Any anecdote?
Yes, so actually there is an anecdote, which is that I didn't know, I wanted to do a PhD in probability. I didn't know too much with whom. And then my tutor at the time told me, well, you know, there is this young professor, he has lots of time, he will take care of you and so on. You should try and meet Gérard Ben Arous. And so that's what I did. I went to meet Gérard. Actually, I was a bit scared because one of my oral exam was with him when I entered École normale, so I was not really excited about doing my PhD with him. But then he was extremely seducing somehow. I mean, he proposed me a couple of projects, but which were always with some applications. So there was, I remember that there was some problem with Brownian motion on large deviation and maybe finding oil in the desert. I mean, and then he also proposed me the other, and then he proposed me another subject, which was more related to which was actually what I did at the end, which was about spin glasses. And again, it had very nice application. It had application to neural networks and actually today to artificial intelligence. So this was all this kind of very fancy probability, but with possibilities of application. So I really liked what he proposed me, and then I decided to do my PhD with him.
Okay, so the next question about the PhD is, can you tell us how you discovered the world of research? How did the PhD go?
So I was very lucky because the subject that Gérard told me about was actually pretty new. I mean, it was completely new actually. I talked with my tutor again at the time, and he told me you should change your subject because it's really way too hard. There was a working group about this subject in École normale. Nobody could do anything. So I'm not going to give names, but then I, you know, Gérard told me to work on that, and I just thought, well, let's do it, you know. And that's what is good when you are young, that you know, your advisor tell you to do something, you just don't ask any question, you do it. And so in fact, this question, which was about spin glasses, which were really at the point where there were very little mathematics about it, even like the equilibrium measure was not as well understood as today after all the work of Guerra and Talagrand. But what we were doing was actually even harder. We were attacking the problem of dynamics and the problem of aging in this kind of models, and this is still actually a very open question. But so what was nice is that even though this was super hard, we could do something. And so then, because we could do something, I had the chance to be hired by CNRS before even the end of my PhD. So I was very lucky because it was a very good question, and so very fast we had some great idea which could be useful to solve some problems, some nice problems. But I mean, now that I had quite a few PhD students, I know that it's not always so easy at the beginning. So,
before we go to what happened after your PhD, maybe it's a good time to ask you about the central character maybe of your mathematical topic, which are large random matrices. Can you explain in easy words, if that's possible, what this is and why it's interesting?
Yes, so I came to random matrices actually because of my PhD in spin glasses. So in spin glasses, you have random matrices which are modeling the media. And random matrices are actually very simple objects. I mean, to define, it's a matrix, so it's a big array of numbers. And they are random, so you take the entries at random. And then you ask the question, what are the properties of this matrix when the dimension goes to infinity? So that's the kind of question that you may ask when you're dealing with spin glasses, but you may also consider this kind of object in statistics to model noisy data, or in physics to model Hamiltonians. And in many other problems and domains, you may encounter this kind of beautiful mathematical objects.
Mm-hmm. Maybe so large deviations, if I'm not wrong, is a common theme of many works you did.
Yeah, that's also something I've been caring a lot about. So large deviations is about the question of estimating the probability of very rare events. And so some people think rare events are not important because you don't really see how much they happen. But in fact, rare events can also encode what is going to happen if you change your measure, for instance. So it's important to be able to understand very finely probability measures, and in particular the probability of rare events. So that's a topic I really love as well.
Now maybe we can try to see where you've been after the PhD, step by step. And so I think just after the PhD you did a postdoc in London with Zegarlinski. Can you...
Yes, so I had the chance to be hired so young by CNRS, but I saw that it would be nice to travel a bit and meet other mathematicians and other fields and other problems. And so I could stay for a few months with Boguslaw Zegarlinski at Imperial College. And there I indeed learned a lot of functional analysis, and in particular related with log-Sobolev inequalities, spectral gaps. And it was very nice because I really discovered new fields in a few months, and we could also answer some questions about the dynamics of spin glasses. So it was a very fruitful encounter.
So soon after London, you go to NYU in New York, where I guess you met many important probabilists.
Yes, indeed, I went in 95 or 96 to NYU, where I could talk with Raghu Varadhan and H.T. Yao, and also Czech Newman, so it was great. I must say, however, it was kind of disappointing at the time because I didn't have the opportunity to work directly with them. I think I was kind of intimidated. But what was very important for me that I followed a class by Varadhan on hydrodynamic limits. And when I came back to Paris, actually, this was really crucial for my research because I discovered with a friend that the ideas that I had just learned in this class, I could use them with him to try to understand better the entropy defined by Voiculescu. And so this was the start of a series of papers which were really important for me.
Okay, so then we keep traveling in the world. So I think you spent an important year at Berkeley, some years after.
Yeah, so about 10 years later, in 2005, I could go with my family to spend 1 year in Berkeley. And this was also a very important time for me. I think that actually all my travels were kind of steps which brought me to new subject. And I don't know, each time I went away, I learned something new and did some new research. And there actually I was going to Berkeley thinking I would work with Voiculescu. And unfortunately, I mean, it did not happen. I mean, that's also the life with research, that you you have some project and some does not happen really. But then I had the luck to work with Von Jones, and this was really something I didn't predicted before I went. And working with Von Jones was a great experience. It was a coffee experience because Von liked a lot coffee, and so we were always working in the coffee shops, and he was doing lots of drawings on the napkins and, you know, with subfactors and so on. And it was kind of very strange because, I mean, he was talking things I didn't know at all, and he was maybe saying things he didn't know so well either. And we were talking and talking with coffee, and at some point, you know, it worked out. There was some kind of alchemy or whatever, and we could succeed to solve some problem that we wanted to solve. So that was great. And it was a great chance to be able to work with Von. He was really a great man.
The only time I've seen a talk by him, he started with kite surf. Did he initiate you to kite surf? Or
actually, yeah, he tried to. He tried to, but I must say I stayed on the paddle. Okay. Yeah, I mean, I regret now that I didn't do that. But actually, yeah, he brought me to windsurfing, which was already quite a lot for me. And
so I would also want to know, are there other collaborators that you met outside of France, say?
Yeah, I mean, of course, I had many collaborators abroad, and there are two collaborators that I had quite early on who were very important to me, Amir Dembo and Ofer Zaitouni, with whom I worked on large deviations and random matrices, actually. Another collaborator who teach me a new topic was Alessio Figali, with whom we worked on transport and random matrices. And this was also a great experience because we were really putting things together. And I learned a lot also in this collaboration. I mean, and there are lots of other collaborators, I mean, with whom I had a great time and great experience.
So now that we've done the outside of France part, so you spent most of your career in CNRS, also some years at MIT. Can you tell us a little bit about these parts that are longer than 1 year visit or a postdoc?
Yeah, so I had also the chance to stay for 3 years at MIT, and this was a great experience too. I mean, to see how a big American university is working, and how students are behaving. I mean, there is kind of different relation with students in France and in the States. But yeah, I mean, this was very interesting, very intense. I think it was a bit too intense for me. And at some point I decided to come back to France and to enjoy again all this freedom that CNRS is giving us, because we don't have to teach as much, and so it's kind of also, I mean, even though I like teaching, it's clear that the freedom that CNRS is giving us is something that is not valuable.
Yes, this is so true.
Unvaluable.
Now that we've seen the mathematicians that influenced you during your career, can you tell us about maybe the more historical mathematicians or physicists, maybe earlier in the 20th century or even before?
Yes, of course. So there are many mathematicians and also physicists who were very important in the field of random matrices, for instance. So random matrices were introduced by Wishart in statistics, and I really had this idea to try to understand data, big arrays of data that had noise, and try to understand random matrices to be able to analyze this data. So this was very visionary, and it's impressive to see that still today his ideas are very modern. And so in random matrices, also Van Neumann is very important, both because he had this impact in operator algebra to understand the asymptotics of random matrices, but also because himself he was interested in random matrices because he understood that measurements had some noise which were modeled by random matrices, a bit like V-chart. Wigner also was extremely important because he had this idea that random matrices could be used to approximate the Hamiltonian of heavy nuclei. And this was a big incentive to study random matrices and how much, how you model these random matrices may infer on the result, on the properties of the matrices. So that's, and also actually in spin glasses, physicists like Parisi were crooks to try to have some intuition about the right problems and the properties you should expect to prove. So yeah, there are lots of big figures in spin glasses and random matrices.
So this is consistent with what you said during high school times. Many doors open, statistics, physics, heavy nuclei, and von Neumann algebra, the whole.
Yeah, that's true. I mean, this is what I love in this domain of random matrices, that it opens to so many domains of physics, mathematics, statistics, also computer science. And so you're always in contact with other fields that you may not know at all. So you're always learning new stuff. And this is very exciting.
Great. So now, if you wish, I would want to know about your approach of mathematics on a day-to-day basis. And the first question, that I have is about students or postdocs. So you had many PhD students and postdocs. How did you behave with them, learn from them? Do you have anecdotes on how it went?
Well, I mean, it's students on postdoc. It's great to. I mean, I enjoy having students on postdoc. It's both a lot of work because you have to make sure that their research is going on and progressing well, but it's also very rewarding because they have ideas and very original ideas sometimes that just surprise you. So you learn a lot, and that's something I enjoy particularly nowadays that I have a ERC grant and I can have a lot of postdocs and PhD students.
Yes, now the Alice group is a huge motivation. Another question maybe related to young researchers. I don't know if it happened to you, it certainly happened to me. At the beginning of the career, sometimes you get stuck in PhD or after, and it's not always easy. So did you experience this, and do you have any advice, or how did you react to this?
Yeah, I think that the time where really I got stuck and again not sure that I will make it was after my PhD when I was just a young researcher at CNRS, and then you suddenly you're alone. I mean, nobody is going to ask you the questions. You have to find nice questions and you have to solve them. So it's it's a whole thing, and it's true that. At some point, I was staying for a long time on questions, and I was a bit desperate. But getting older, what I realized is that very often I try to have a few different problems, and that's also what I do with my students. I always propose them to have at least two questions to think about, because when you get stuck on one, then you can think about the other, and hopefully things overall will get better.
Maybe I have a small anecdote about your approach when you are stuck. Or it's not about math, but about bike. But the first year I arrived in Lyon, I used to bike to the department like you do. But during the first winter, at some point, it was absolutely awful. It was raining and then freezing, and the whole city was like a skating kink. And of course, I take the subway to reach the lab, and then I meet you in the corridor, and you have all the bag, the helmet, the bike equipment, and it's so. And I'm shocked. Like, Alice, you took the bike and you looked at me almost as surprised, and you answered, "Of course. What else?" And I thought, okay, so Alice takes the bike even when it's snowing and crazy outside. So probably with math problems, it's the same. I don't know if
yes, maybe. I mean, I think, but maybe bikes are kind of easier than math problems sometimes. But it's true that, yes, I like to bike to work, and I think it's a great moment to be calm and, just to get in the right spirit to start working. And actually at MIT, they were even more surprised to see me with my bikes, with the snow on -10 degrees outside.
There is even more snow, right?
Yes. But I think it's biking is a nice way to get into the right mental disposition.
Yeah, I did not apply that advice during winters here. About the approach to mathematics, I have another question, more a curiosity. So, what I prefer myself in math is when I get to be surprised when there is something counterintuitive. So did you ever either prove something you found counterintuitive or learned about something that was very counterintuitive to you?
Yes, indeed. In fact, very recently I was very intrigued by a result. And this is related with the questions that I worked on Voiculescu entropy. And it's actually a kind of simpler questions in some sense, which was asked by Alain Cohn in his PhD. And so the question goes as follows. So if you consider probability measures, you know by Birkhoff's theorem that you can approximate it by sum of Dirac masses. And the non-commutative equivalent is kind of, you replace the probability measure by a threshold state, and you ask yourself if you can approximate it by traces of polynomial in matrices. So it's kind of the non-commutative analog, and for me it was clear that, like for probability measure, they should be true. But apparently it was proved that it is not by some work from people in computer science. I don't remember all the people, but Vidic and Wright are in this collaboration. And so, yeah, this is very intriguing. And also this asks question actually about this Voiculescu entropy, because for Voiculescu entropy, what you want to understand is the volume of matrices which approximate a given threshold state. But of course, if you have a very bad idea of what is the limit of this polynomial in matrices, how are you going really to solve this kind of question about volumes? So that's very intriguing, and still I hope I will understand it better in a close future.
Very good. Now I have a special question for you that I just thought about, a kind of a revenge. So you were in the committee when I passed the interview for CNRS, and I just remembered you had a question to me, and I will ask you the same question. And because I really liked the question, so you asked me, what is the result you are the most proud of? So I wasn't sure what to reply, and today I ask you, what is the result you're the most proud of?
Well, I think all this question about Voiculescu entropy, which I've been working, since my PhD thesis, are still very much in my mind, and I love what we did. And I hope to do more. So that's clearly one result I really like. But in fact, also recently, I came back to my PhD thesis with Amir Dembo, and in fact, I realized that really, looking backward, we did things. I did things which were quite nice. So, it's always difficult to choose. In particular, when you go back and you realize maybe you don't understand what you could do 20 years ago. But But okay, I think all this line of questions around Voiculescu entropy was something that I really like.
I also want to ask you about books. You wrote one book about random matrices, in fact 2 books that are influential. Can you tell us about how it started? Any stories about those books?
Yes, so it's actually very easy to start a book, and it's not as easy to finish it. So actually I have one book which started already 7 or 8 years ago. I hope we will finish it. But so this book you talked about with Greg Anderson and Offer it took us 10 years to complete it. And that's quite long, but I'm very happy we did it. And actually it started very nicely. And it started in a summer school in Brazil, and where I was with Offer Zaitouni, but also Chris Birdsey. And for this summer school, I had done some small lecture notes. And Chris then came to me and he told me, Alice, I have to tell you about some philosophical question. And I was thinking, wow, what is he going to say? And then he just told me that, Alice, I think it's the right time to write a book in random matrix theory. And because it's important so that, students can go in the subjects. And this is the right time for random matrix theory to have, a basic book where students during their PhD can learn the theory. And so I thought, well, that's quite a good incentive. And then I talked with Offer, and it turned out that with Greg, he was also thinking to write a book. So then we just started the project, the 3 together. And it was quite a tough experience. I mean, a book is always a big adventure, but I learned a lot from it, and hopefully other people also learned from it.
So now I would want to ask you about the ICM. So you're invited as a plenary speaker at the ICM. Can you tell us what an ICM represents to you, and what it feels like to you to be a plenary speaker at this big conference?
Well, of course, it's a great honor to be a plenary speaker at the ICM. And I think ICM is a great opportunity for the mathematical community to meet together, and also to have kind of a snapshot of what has been done, important recently in mathematics. And also, to actually go and listen to talks that you would not listen to otherwise because it's far from your field. But somehow, that's a great opportunity to, get this snapshot of mathematics.
Maybe especially for someone who likes to have many doors open.
Yes. Well, I'm not sure I will be able to take all the doors at ICM.
So I will finish with some concluding questions. And the first one is that there are very few women in mathematics. And the first question is, do you have any explanation for this fact? And the second question is, do you have any useful advice to give to female mathematicians?
Yes, so yesterday I was thinking you would ask me this question. And I was talking with a student of École Normale, and I asked her the question, so what does she think about being a female mathematician? And then she said, well, people don't think you will succeed in doing it, will not be able to make it in science. And
people,
I think it's,
the professors, the students?
Or your friends, or it's just because you are a female, there is kind of a priori that it will be harder for you to make it, and therefore there is always this kind of feeling. I mean, personally, I experienced that when I was during my high school. That friends were just stopping being my friends because they were thinking I was kind of a nerd. I was not a true friend because I was too good in mathematics. Because they didn't.
Or in bike.
Because that's what people just expect, that you're not supposed to be men may not expect that you're going to be better in mathematics than they are. That's the point. And I think it's quite true. So I experienced it a bit. And the point, I think, is that because there is this kind of global feeling that women should not be as good as men in mathematics, then women also believe that. And so they don't think that they will succeed. And I really had this experience myself. As I said, I never thought that I would be a researcher in mathematics. That was not something made for me. And when I discovered that actually I loved research in mathematics, and that I could be eventually good at it, it was a surprise, a very good surprise. So I think it's this two-sided, that the society believe that women should not be as good in mathematics than men, and women also think that because they've been used to this kind of thoughts. And so if I have an advice to give, it's just, you should be confident, woman in mathematics, that you can make it. And that women are as good in research in mathematics than men. And therefore, at least you should try it. And it's true, once I gave this advice to young women in mathematics during a talk, and I had a few women who wrote to me afterwards saying, well, I was not thinking that this was my place. Thank you for saying this. And I realized that this was just some kind of pressure that I got all the time from myself and from people around me. So I think that the main advice I would give, forget about all the a priori, things it's a priori, and try it, and try to do your best. And maybe you will find it's your way.
Great. The second concluding question that I want to ask you is, so you're plenary speaker at the ICM with a very wide expertise in probability and its connections. Can you target a few important goals for the future in random matrices, or maybe more generally in probability theory?
Well, maybe I can. I mean, probability theory is huge, so let me focus on random matrices. I think that, in like 20 years ago in random matrix theory, mostly integrable models were really well understood. And so this was models for which are enough symmetries that you can make lots of computation, like getting explicit joint law, explicit computation, and so on and so forth. And this was really the beginning. And now there is more and more work to show that even if you have less symmetries, less properties, you can still study random matrices. And I think that the future is really to be able to generalize this approach to less and less symmetric models with more and more sophisticated structures. And this is also motivated by applications. I mean, applications ask for more and more random matrices which have intricate structures, and so that's clearly, I think, what will happen in the next 10 years, that people will try to crack this type of question.
And my last question is a bit going back to the beginning. So you said that until rather late, around 20 years old or so, you wanted to be rather an engineer, and then you switched to becoming a researcher in mathematics. So for the young people that are still watching this interview to this point now, so they're probably motivated in math, what would you tell them to if they probably think of a possible future as a mathematician for themselves? Or do you have any advice to young people thinking of possibly becoming a mathematician?
Well, Well, I think that maybe they should follow. I mean, there was some survey recently saying that being a mathematician is the nicest job ever, and I think it's quite true. So I think they should really try it. And you research in mathematics, like maybe many things, you know if you like it only when you're really doing it, and that's at least what I did, and I think it's a beautiful work. So I think they should try, continue, persevere, because also yes, research is it's really great. I mean, it's lots of extremely nice moments, but it's also lots of work. So you have to persevere in mathematics, and
I agree with Alice. It's worth it. Okay, so I enjoyed a lot playing the role of the journalist.
Thank you very much, Christophe, for doing that. And I enjoyed a lot your questions, even the trickiest one.